Chapter 8 in your book is about concrete. We're going to spend the next few minutes just going briefly over the chapter. You should read it, and it is an important chapter for our project because there is a lot of concrete work involved. Concrete's a useful material that you'll find in a lot of jobs, most jobs actually. It's formable. You can build a form to shape it into almost anything. It has good compressive strength, very good compressive strength, and if you put reinforcing material in it, it also has a good tensile strength. So it's an all-around kind of material for especially decorative type work more and more, but also it's a good basic structural project. You'll find concrete that you can see when the project's done, and also a lot of concrete that is buried or embedded somewhere on the project. Just as we've mentioned several times already, the most important thing when you're doing a takeoff and pricing for your concrete is to review all the drawings, and that just like you should read the whole chapter, you need to read all the drawings, you need to read the technical specifications in the book, especially in the project specifications. The numbers you're going to see referenced here are concrete is in Division 3, the Construction Specification Institute breakdown of project materials and components. So we're going to talk about CIS Division 3. And when we get to the estimating software, that's also where you'll be looking under Division 3. One thing that's real important is that you not only should read the obvious chapters and sections in the plans, but you should also check the other sheets, such as the mechanical and electrical sheets, and we have those kind of sheets in this project. You should even look at the landscaping sheets, because what they're going to show is different uses of concrete, and most importantly, you're going to see things like box outs for piping and conduits, and pads for holding things. And I'm not going to tell you what they're holding. You can look around on the projects and find them. So it's not just those obvious curb and gutter or flat work pages. You have to look at all the pages, and don't forget that we are building a fountain, so you need to look out there, especially for things like box outs. And you need it not only for the estimate, but also for scheduling how you bring trades into a project. When you're looking and considering concrete and doing the estimates, you can organize it into a number of different categories. Now, again, as we've been mentioning, there's no right way to do an estimate, and there's no right way to finally break down things. But in general, you have to consider things like materials, the formwork and the placement of concrete, the concrete finishing, curing, reinforcing, embedment, again, not blockouts and things like that we just mentioned, and if you're using any precast concrete. And precast concrete, by that we mean concrete that's made off-site in a factory, or sometimes it can be made in a factory, such as tilt-up, or on-site, such as tilt-up walls, which will be formed on-site in a work area and then moved over or lifted up. The thing about precast concrete and why it's more and more popular, especially when you think of things like Rapid Construct, is that in a factory you can control the conditions much better. You can ensure mixes are to the exact quality that you want. You can cure the concrete in controlled conditions. So more and more we use precast concrete. It's a good choice if you can, but still, again, if you have good working conditions outside, you can do a lot with your concrete. One thing you have to remember with concrete is that, the basic process that turns concrete or cement and stone and sand and water into concrete is hydration. and you need water to hydrate. You need liquid water to hydrate. And that's where weather comes in. Extremes in weather that affect the water, affect the hydration, and so affect the strength of the concrete. You have to be careful that you don't do work in cold weather, especially freezing. You don't ever want to have concrete that freezes up on you. And again, I think the book says it will never achieve full strength, but over time, and I'm talking tens of years, you'll get the strength, but it's certainly going to slow curing down if it's frozen or if the temperature is low, and I'm talking below 50 degrees actually. The buildup of strength in concrete is a lot slower than if it's above 50 and say into about 90 degrees is optimal. If it gets real cold, you can place concrete, but you need to cover it, you need to insulate it. Potentially, if it's going to be real cold for an extended period of time, you're going to build a cover, and you're going to put a salamander or a heating unit in the covered area to keep the concrete warm. On the other hand, if it's too hot, the danger is if it's too hot, water evaporates, so there isn't enough water for hydration to take place, and so you have to be very careful. In cold weather, you may add hot water. In warm weather, you may add ice to the concrete to keep it cool and to keep the temperature properly. So again, it's very important for the mechanical purposes of the concrete and the strength to protect it against weather extremes. One of the other things that you have to consider when you're working with concrete is that when weather conditions are real bad, it slows production down. It's not good for your crew. It's very hard work. Concrete finishing crew working in the hot sun on their knees and it's just production goes down. And there's also always a temptation to water the concrete down to help them finish it when it's real hot, which again makes a problem. You'll get spalling later on. So both for the concrete and for the people who are doing the work, extremes in weather are good, and you want to consider that, especially when you're scheduling a project. And that's the second point. You want to do concrete work when the temperature is optimal. And so as you schedule work, you're going to consider when the concrete work is going to take place and how it times out on your schedule. And you may either be moving the whole schedule or you may be moving other activities to slide the concrete into good temperature range. You'll see in Chapter 8, for each of the items that we talk about, there's a discussion on takeoff quantities and the units of measurement that are generally used. In the case, say, of concrete material, we generally talk about cubic feet or cubic yards. And remember, 1 cubic yard contains 27 cubic feet. So generally you order concrete from the mixing company or the concrete company in cubic yards. But each of the sections has takeoff quantities. I'm not going to discuss all the takeoff sections, but you need to be aware of them. And especially when you go and work in the means program, you're going to see the units. If you don't understand the units, come back to the book and read the section. And you'll be able to determine what unit you have to work in. And it's very important to keep your units consistent, use the proper units, and when you're doing your takeoffs, every time you write down a number, put the units next to it. So, for example, you're measuring a piece of sidewalk and it's 10 feet long, 5 feet wide, and you're going to put a calculation on your worksheet. 10 times 5 equals 50. After that, you're going to put SF, square feet. And then we know what the units are that you're working on. And then when you take into consideration the thickness, you're going to multiply it by, say, if it's 4 inches thick by 0.33 foot, and you'll end up with your final answer, which is going to be in cubic feet. And you're going to put a CF after that calculation, and then you're going to divide it by 27, and you're going to end up with cubic yards. And we're going to want to see the units after each of the calculations. A bare number doesn't mean anything, and it has no units as far as we're concerned, and we don't know what it is. So as you do your takeoffs, remember to include units everywhere. And remember to look in each section as you're doing a particular takeoff to use the proper units. There's certain factors that affect the strength or the price of concrete, and you have to take that into consideration, because what you're going to want to do is break out each different type of concrete into a different takeoff area, because they're going to possibly be different costs. For example, if you have different strengths of concrete, you have some 3,000 psi concrete and some 4,000 psi concrete, you're going to need to do the takeoff for each of the for the 3,000 psi and one for the 4,000 psi, because it's going to cost more for that 4,000 psi concrete. Why? Because it's probably got additives in it, and certainly it's got more cement in it, which makes the cost higher. If you're using additives to accelerate or retard the curing, calcium chloride, and let me tell you about calcium chloride. You don't use a lot of calcium chloride or any at all if you're using steel reinforcing. Obviously it's going to rust and cause you premature failure of the concrete, but there are other accelerants and retarders out there that you can use. Again, if you're using retarder on some of the concrete and some of the concrete has none, then you need to split the takeoff into two separate areas. The type of aggregate that you have, the gradation of the aggregate, again, if it's all the same and all the strengths are the same and they all have the same additives in it, then it's one takeoff. But if you're using different concrete with different additives or stone size, then you need to break it off separately. Where would you find different stone size? If you're placing concrete for a sidewalk, you can use a larger aggregate. Again, the specifications will tell you how much. But if you have reinforcing cages inside of a column form that you're going to be placing concrete in, your aggregate size will probably be less, because the largest size aggregate you can use has to be able to fit between the reinforcing cage bars. Right? In that case, you're going to have some different concrete. Air, how much you have. If you're going to use an additive for air, again, you're going to break out separately. And also, if you're going to use different cements to make the concrete mix, you have to split it out based upon the cement. So when you do your takeoff, remember to break each type of concrete, different type out, label it, what type it is, and also have the units on it so we can see what you got. There's a certain amount of wastage whenever you do construction work, and concrete is no exception, and you have to account for wastage. Generally, you're going to add about 2% for most projects. If you have to haul concrete a long ways, or you got some special condition, you have to run it through a pump or something like that, then you may have a 5% factor. But I hate to see this much. I generally don't see this much concrete. A good concrete crew doesn't waste concrete. Remember to put extra in for wastage. And when you do that in your calculations, you should indicate that which percentage you're using, and then mark it as a wastage calculation and the total amount of cubic yards that you need. In the same vein, when you're purchasing concrete, more and more we use ready-mix concrete. Why? Because it's made in a factory, in a plant, and so we can computer control the mix, the exact amount of stone, sand, water, cement. It's protected, it's done under managed conditions, and you can manage and control the transit mixer of the truck. So the thing is, though, again, when you order a mix, so often you'll count on a full load. And it depends on the truck. You'll see different types of trucks out there. 10 yards, 15 yards. More than that, and the truck is overloaded, and you can't really use it on public streets. You could use a larger haul when you're working interior to a site. But for regular transit mix, you're talking about 10 or 15 yards. Now, generally, you don't always need, well, generally you're going to order a full load. You get your best price. But there are some times on your schedule when you can only take a part of a load. Generally, when you order less than 5 yards, it's called a short load. So 3 to 5 yards is a short load. If it starts getting smaller than that, then you really need to start doing something with your scheduling, so you don't have a truck coming out with a yard of concrete. And again, you're going to get poor quality concrete. It's going to get beat up in the truck, and the air is going to come out of it. So you'll have a hard time with that concrete finishing it, and durability is going to go to pot too. So remember that if you are scheduling a job and you have to use a short load, you're going to pay a premium, where it may be $80 or $90 or $100 a cubic yard for a full load. A short load might be $150 a yard. So again, it's a real price matter if you order a short load. Because concrete is plastic or almost liquid, during its placing, you need to have forms to control where it is and its shape. And generally, you're going to use wood or steel forms to hold the concrete in place. Why wood or steel? You need something that's durable. Remember, concrete's a heavy material. You need something that you can bolt or nail together that can withstand the loads that occur when you're placing the concrete in the forms and when the crew is working with the concrete. So you need to calculate form placement, and again, we won't go through much of the exercise to calculate the kind of form work, and there are some programs and things. If we have some time, maybe we'll look at them, but right now you're going to make a best estimate as far as form work and go from there. But you do need to calculate the cost when you're doing form work of the material you're using, the time to build forms, and the time to take the forms down. Remember that when you're doing form work, you're not going to use necessarily that concrete finishing crew. They're going to be finishing. Their specialty is finishing concrete so that it looks good and has strength and is durable. Forms are built by carpenters. At least accurate forms and forms that are built quickly and efficiently are done by carpenters. So you're going to have different crews out on the site when we're doing concrete, getting ready for it. Carpenter crew is going to be out there building forms after you've brought things to grade, and then the cement finishing crew is coming in to finish the concrete. The carpenters will come back to strip the forms and to move them over to the next site, and then the concrete finishers will come in, so you have a rotation of those two crews working on your site to be able to do all your concrete work, and scheduling them is an important task. What this diagram shows, it just is a couple different types of shapes of concrete. A continuous footing that you'll see under a foundation wall, or isolated footings that'll be pads under, say, a column. This might be the kind of footing that's done under, say, a fountain. And this would be under a column somewhere, although you have to check the plans to make sure you know what you're using. But you're going to use wood forms or steel forms to make these shapes of concrete. Again, you just don't want to throw down a blob of concrete in the ground. It's a waste of material. It doesn't transfer the loads, and that's what these devices are for, to transfer the loads that they're carrying efficiently to the soil beneath them so that you have a stable, strong structure. So you need the forms to make an accurate, neat form or shape so that you can accurately transfer loads. When you're building a footing of some sort, remember that you're going to have dowels or rebar coming out of that footing to be able to attach onto, say, the footing walls or the walls that you're setting the footing on, or the column that you're setting on. And again, placing that steel has to be done accurately. You need to have the proper spacing in order for it to carry the structural loads that it's designed for. Even more importantly, well, just as important, is that you need to make sure that steel is accurate. You need a certain thickness of concrete between the exterior of a wall or footing and the steel to protect the steel reinforcing rod. Otherwise, water, chlorides, other chemicals will get in there. If it's not thick enough, the separation is not thick enough, and they will rust the steel. When the steel rusts, it expands, it gets wider. And it's that expanding that then pushes the concrete and spalls the concrete off, and then your project is on its way to ruin real quick. So when you're doing something like a spread footing or that isolated footing we looked at a minute ago, you're going to be, again, worrying about the takeoff. And the takeoff is going to include planks or panels of wood. You're going to use planks, plywood, small stakes to anchor things, nails. A lot of items go into preparing a footing, and so you have to, if you're going to use nails, you have to account for the number of nails that you're going to use so that you can buy nails and charge them off to the project. You can't do it for free. So again, look at the takeoff quantity sections and you'll be able to see the kind of items that you need to consider, or how you, what units you use. Again, you'll see on this drawing, you'll see the planks that might be set in place, kickers that will hold and support the planks. And again, you need a lot of support. Concrete is heavy, and again, when you're putting it into these walls, there's a lot of loads against the forms, and catastrophic failure happens if the board comes loose or you didn't put enough nails in it, it pops. Concrete starts moving all over the place. You not only lose the work, it can kill or injure a worker, your finishers, or your crew, and we don't want that. Above all, you always want to do things safely. When we do a footing, often a continuous footing, as we were talking about, we often put a keyway in it. I think you'll find a keyway on our plans somewhere if you take a good look. The keyway is intended when you set the next layer of concrete, the wall or whatever it's supporting on top of it. The keyway extends from that piece down into the footing, and it keeps things from sliding around, so you don't have to worry about the wall slipping off the footing. But you have to, again, use separate, specially shaped lumber to make the keyway, and you have to remember to do it when you're building the footing. Again, it's another piece of wood and some time for a concrete crew to insert it and to be able to do it right. You'll have, I think, some items that look an awful lot like this for your project. And again, look at the plans and you'll see a footing or footing requirements similar to this. Just remember that when you're building that footing, there's excavation. Obviously, there's forms, there's support materials, lumber. You have the rebar that has to be inserted, then the concrete. So there's a lot of different pieces, and that's what you need to do, and make sure that you've included it at least somewhere on your estimate. We don't want you to double count anything, but make sure that you have everything that you need when you're building a piece of work. Again, once you have the footing in, and then you're putting something on the footing, whether it's a column or a wall of some sort, the interior of a fountain, for example, and you need to build some forms. And you're generally going to have plywood or large wide planks. You're going to have ties. You're going to have different amounts of whalers, and to hold the forms in place. And inside the forms, you're going to have some reinforcing bars to provide strength. So again, as you're looking at the work and scheduling time, it takes carpenters a while to build something like this. You also don't often do a whole piece of wall or a whole structure one time. You do part of it because you're limited by the size of the lumber that carpenters can handle. And remember, sheets of plywood, a 1-inch sheet of plywood or 1.5 inches, whatever you're going to be using, is a heavy piece of material, so you can't expect them to handle more than a 4x8 sheet at a time to be able to put things together. That's part of your job, though, is to schedule that work and to consider what the carpenters can do. Just wanted to mention, remember that when you're pricing out forming a wall, the price is affected more by the size or the height of the panel that's being used than the amount of concrete that's going in. You don't have a lot more difficulty putting concrete in as long as it's in excessive height. You want it to come out. Of course, if you're going to be filling a wall and you're using a transit mixer, the wall where you put the concrete in can't be any higher than the bottom of the trough that the mix comes out of the truck. If it's a higher wall, then you need a pump. And at that point, again, still concrete isn't the governing cost factor. It's that truck that carries the pump, because they're a very expensive piece of machine. You usually have to pay for a pump for at least 4 hours guaranteed, generally a day. And when you're talking about maybe $500 or $600 an hour or more a day of a truck for 8 hours, and if you only need it for an hour or two, you can see how the cost is going to run on you. So remember that at least when you're looking at the form work, also when form work gets high, you need other things for the carpenters and the people who work on. You need scaffolding, safety, a lot more safety items to prevent falls and things from falling off and hurting workers. So as things get higher, they cost more proportionately, I think. One of the most common types of forming you'll see, especially when you're working in concrete, is edge forms, and basically they're made out of rough timber, generally 2x4, 2x6, 2x8 if you got real thick concrete, say for a driveway. But they basically are staked around the edge to form the shape that the final concrete is going to have, and then you place the concrete inside. But again, you still need lumber, nails, different sizes of stakes, things like that. Also, there are a lot of steel forms that you see that are used. Again, problem with steel forms is that you have to protect them. They get bent and damaged, and then you're out of luck. Lumber also gets bent and damaged, but you can often cut good pieces off, use it for stakes. And what you want to plan for is that you're going to use the timber for, say, 3 or 4 times and dispose of it anyway. By then it will not be usable. So if you do a lot of edge forming, steel forms may be good. Again, if you've got a good crew that takes care of their equipment. If you don't, or you're only going to do a couple small jobs, then timber is probably most economical. Again, one of the things we'll talk about, and I think we've already used the term, but generally sidewalks, slab on grades, is called flat work. Okay, plain decorative concrete or flat work, and you're going to use an edge form on it. So you're going to finish the surface. You're going to use trowels and brooms or stamps. Again, one of the things that you can do is color any concrete or stain it, and you have to read the specifications to see what you're going to do. When you're looking at moving the concrete and doing flat work, again, there's different ways of placing the concrete in the edge forms that you're going to make. You can run the concrete right out of the truck through its trough. You can use a pump, which is expensive. If you need to move the concrete a ways, you might use a mechanized buggy, or if conditions are really tight, you may have to use wheelbarrows. And again, you can see the more you handle that concrete, the more equipment you need, probably the more your cost is going to run up, and you're going to need to break your concrete work down by how you're going to put the concrete in the forms, in addition to those things we talked to right at the beginning. And just to round things out for you, and you should look to see if you need any polishing done on concrete here, but there are different finishes you can put for general flat work. Broom finish of some sort, or burlap dragged finish will work, but you also can grind concrete to make it flat, especially if you need tolerances for setting equipment. You grind it. You may hone the concrete, and this brings it and starts giving it a light polishing, but also makes it more flat and accurate. Or you can polish the concrete, which is reflective. It'll shine back at you. It's pretty for building interiors. Outside it's not so good because it can get slippery, and if you have snow and ice, then it will get slippery. Read your specs, see if you need to do any of this. Figure 8.9 is a helpful table that you should spend some time looking at. It gives you an idea of what kind of labor is involved for different concrete flat work activities, slab on grade. Okay, so you can look at this, and these are the information that are incorporated in the means calculations. Now, these are base means. These are based on averages that means come up with. You can, when you're making your estimates, change these numbers. Use different ones if you want. If you know something about a project or how you want to do it. All we ask is that whenever you make an estimate or you change what means has, that you write us a paragraph that we can see, that you probably put in an appendix together, or on your takeoff sheet is even better, but tie it back to a page number so that we can see what number you used and the rationale behind it. And as long as there's a good rationale for it, that's perfectly acceptable for us. Remember, we are the final owner of the company that you're preparing a bid for, so we want to make sure that we know what you're committing us to. And that's what happens when you change these numbers. You're committing us to a different number that changes production and cost. So spend some time looking figure 8.9. Let me just point out, say for example you're doing fine grading for a slab on grade. And for every square yard that you have to fine grade, and that's the square yard of area of that slab, then you need to have 0.010 hours of labor to do that activity. And for all these other activities, you can see the amounts of time that it takes. And altogether, they give you a slab on grade, at least from the point of fine grade up to the steel trowel finish. Okay. But it doesn't include, if you look here, right, the forms. Concrete is almost like a living being. When it gets hot, it expands. When it gets cold, it contracts. You have to incorporate joints. You're going to put basic preformed joints into concrete along edges against walls so that there's room, especially for concrete to expand, that it has a cushion. Otherwise, if it has a solid object, the forces of it being pushed against the solid object will cause cracking. There is a cost not only for the pre-molded joint filler, some type of fiberboard, but there's also a cost for your laborers to put it in. So you have to account for that. Similarly, you need to put control joints in, and there are a number of ways you can put control joints in, but again, they control cracking. There are natural places that concrete will crack, and that's why you see every 5 feet on a sidewalk there is a line, and that line are control joints. You'll also see a fiber joint in two, generally, say every 100 feet or so, or every few joints will be a fiber joint, but the rest of those control joints are put in either with a saw or a tool. They don't go all the way through the concrete, but they're there, and when the concrete eventually does crack, the hope and the idea is that it will crack and finish cracking through where you've put that control joint. So control joints are very important for the longevity and the attractiveness of concrete, especially for our project. You need to make sure that there are plenty of control joints and that they're put in. As you're building, you provide time in your schedule to do it and cost to put them in. With a tool, it takes extra time to tool them in. Or if you bring a saw in later, you have to account for the saw and the crew to bring those in. And the big diamond blades they use are expensive pieces of equipment for you to use, but you do need them. You can't build concrete without joints. You have to also cure and seal concrete. Generally, you're going to cure it, or depending on the material you use, there are curers and sealers together. But for flat work, generally you're going to apply a curing compound, and you're going to put that on after the concrete's been finished and it's been allowed to set up slightly. Then you're going to spray it down with the curing compound. It's that white spray that you see on concrete. There also are clear curing compounds. I always prefer white because I can see how it's been applied to the concrete, if it's been done uniformly and if anything's been skipped. So it's a quality control item. The curing compound, anyway, forms a membrane over the concrete, and the membrane helps slow down or evaporation of water in the concrete so that it has time to hydrate and cure for you. So it's a real important step to have. You also can spray down concrete again after it's been allowed to cure up, and you don't have to worry about washing away the fines on top. But you need some type of material to cure it. Sealing will go on sometimes again with a curing compound, but sealing also can go on later. What it's intended to do is to hold the surface of that concrete in place, especially where you don't want dust to get away from the concrete, or oils or other materials that you may be working on, say a floor of a garage. Put a seal on it, and that'll keep oil or other fluids from soaking into the concrete, marring it, staining it, and in some cases deteriorating the concrete. So again, you need to read your specifications to see if you're going to be curing and sealing. You always want to cure. You may or may not seal. Read the plans. And the important thing I mentioned right at the beginning is concrete's good in compression, and when you put reinforcement in it, it's good in tensile strength too. And there's a couple different things you can use. You can use welded wire fabric, and you often see that it's mesh. People call it a lot of things, but it has a square pattern of wires, and you can use welded wire fabric. Again, you have to place it carefully. You need stands to set it to make sure that it's embedded in the concrete at the right depth to be protected from moisture. There's equivalent between welded wire fabric and reinforcing bars that you can transfer, but for you as a contractor, you're going to put down what the designer specified. You may in some cases do some value engineering, but you can't arbitrarily change reinforcing bar to welding wire fabric because you think it's best, or you have some sitting in the back 40 you want to use up. You can see this table will tell you the characteristics of the welded wire fabric, the sizes. So again, you can plan for moving it, for purchasing quantities, okay, and to do estimating for how many rolls of it you may need. Figure 8-1-12 just gives you a better idea of the dimensions of the fabric and what it looks like. Reinforcing bars are, I'd say, the primary type of reinforcing that you'll see, and you'll see it specified in the plans in a couple places, so make sure and look at the plans, all the sheets to find it. Rebar comes as designated numbers, and generally there's 1/8 inch diameter or nominal diameter increase, so you'll see a 3, 4, 5, 6, 7, 8, and every number 3 bar is 3/8 of an inch. A 4 bar is 4/8 of an inch. And that's generally will be specified in the plans, and you shouldn't make substitutions because the size of the bar relates directly to the structural strength and the tensile strength in particular of the finished product. So you don't make substitutions. I don't care how much you have in your yard. You stick to the specifications. Now you can talk to the designer about it if you want, but I don't recommend it. It's generally not worth the time. Figure 8.13 shows you the characteristics of different reinforcing bars. Again, you can see a number 3 bar way over in the left-hand column has a nominal weight, pounds per foot, 0.376, has a diameter of 0.375 inches, right, 3/8 of an inch. Gives you the area, the perimeter, and also gives you international units. Why do you need to know the weight? Because you end up potentially buying reinforcing steel by the pound or the ton if you have enough of it. So you need to be able to calculate first the number of bars that you need for a job, and then you calculate the weight of those bars, and you translate those weights again either into pounds if it's a small amount, or if it's a ton or more into ton, and that's how you're going to see the steel placed. Now when you're doing that calculation, remember that there's wastage and overlap. Just like when you have different types of concrete and you're going to do your takeoff separately for each type of concrete, for each type of bar you're going to do a separate takeoff and calculation. If there's number 3 bars, number 4s, and number 5s, then you're going to do a takeoff for 3 bars, for number 4 bars, for number 5 bars, all 3 of them separately. Label them so we know which bar you're calculating. Also, when you have to use a number of bars and put them together, you have to overlap the bar. It's in order to get the strength and to transfer the strength of the bars and the loads up and down the reinforcing bars, and that's usually specified by a number such as 20D. Okay, and you can see it down here in the example. We're going to overlap by 20D. And what that means is you're going to have an overlap equivalent to 20 times the diameter of the bar. So if you got a 4-inch bar, or a number 4 bar, remember that's a 1/2 inch, 4/8, or it's a 1/2 inch diameter. So if it's going to be 20D, it's 20 times a 1/2 inch, or you have an overlap of 10 inches. So each place where you bring bars together, to make a longer length, you have to overlap them 10 inches. And so you have to calculate that. And this calculation shows you how you do that. Just remember that if you don't do the overlap, you're going to be short. Also, when you're working with the reinforcing bar, there is a wastage. Sometimes you cut a bar, or you have to cut bars. So you have to account for both of that to get the right length. Generally, you'll find designers try to use whole bars or segments that minimize the amount of wastage. But remember to do that and include that in your total amount of pounds or tons, whatever it comes out to be. And I've skipped a couple sections and gone down that you can read. I don't think they really apply to this project, but read them for your own information. But you probably will have some embedded items, or at a minimum some sleeves. You need to look at the plans and you'll find, remember, embedments or sleeves are places to make holes or openings or throughways inside your concrete work. So if you're going to do those, you have to account for the material you make a sleeve. And what are you going to make a sleeve out of? Well, it may be a piece of PVC pipe, or you may make a wood box, insert that, or use some other type of firm material. Remember, this is going to be placed and going to be in a form when you're placing concrete in it, so it has to be able to withstand the load of concrete being dumped on it. It's going to be nailed into place into your form so that you can account for it. What do you have to account for? The number of sleeves, the amount of pipe that you need to make the sleeves, and nails to name it in place, the labor to make the sleeve up. Similarly, you're going to have anchor bolts that you're going to need if you've got a footing wall of some sort or an isolated pier, and you have to account for placing the anchor bolt in. If you forget putting the anchor bolts in, then you're going to end up generally doing the work over again. You may in some cases be able to talk a designer into letting you drill or epoxy something in, but I for one wouldn't allow you to do it. You take the footing out and start over again and do it right. And just like we looked at the table a couple minutes ago, you'll see that here's a table that talks about the amount of labor hours and the unit type or units that you use for different types of activity. For example, placing concrete or direct shoot method coming right out of the truck, 0.873 hours per cubic yard. Okay. Or if you're going to pump it, 1.28 hours per cubic yard. If you use a crane and a bucket, you see probably even more expensive for a lot of reasons than a pump, 1.422 cubic yards. But again, this gives you an idea. If you use different ways, you have to use different ways to put concrete on in a project, then you have to account for the fact that they're all different costs, different amounts of time, and that's what the time is. The time is money. Again, there's a number of other items, and I recommend you take a look at them. I should read the whole chapter, but accurately estimating the concrete is important. Okay, you need to be able to do that. You need to be able to account for all the items that you use, all the materials, all the concrete. You need to break it down by all the different types of material and work that you're going to be doing so that you can get a total cost. And remember, most of all, I think, when you're scheduling a project, time is critical. When it's done is critical because that can affect temperature. Temperature affects the quality of the concrete, the workability, how you get the job done. So, and as we get into the scheduling later on, I want you to keep that in mind. As you read the chapter, just remember to go ahead into your means program and take a look at it. And if you haven't gotten into it, it's time you get into it. One of the first things you'll come up to is a welcome page that talks about some different items you're going to use. For example, labor type. This is an open shop job. It's not a union job. You can either be unionized or non-unionized, so it's an open shop job. Its location is here in Kansas City, so you need to put that in. You need to set these parameters, and you should all set them the same. So, or if you aren't going to, so you don't have to set them the same, but you have to set them and tell us why you did it. And as long as it makes sense, that's fine. That's what you need to do. If you go to search data, you'll come up and you'll see a sheet like this, and then if you go, remember we're looking at section 3 of the master format, concrete. If you click on that, then you'll see a number of different types of work. And for example, you click on 311, it talks about forms and formings that you can use and the different factors that you're going to have for forming concrete. So take a look at those. And now we're going to give you a line number to tell you what's there, but it'll tell you the work, forms in place, footings, continuous wall, plywood, one use. Remember, that's how many times you'll use the plywood. And it'll tell you the unit, square feet of contact area, a particular crew, a C1 crew. And I'm not going to talk about crews in this, but it's a particular staffing to do the work, and daily output, 375 square feet of contact area. So if you go, just take a look now and start looking at the different items, because you're going to be using these different items to base to be as a base for your estimate. Again, if you're going to change anything, you need to justify it to us. Tell us what is recommended and what you're using and why you're using it, so that we understand as the boss and we know and agree with you. Right? It doesn't take a lot of words, but it needs some words, and they have to be referenced to the page of the plans, back and forth, so we can tell where you are.